Hi. In this problem, we are going to look at a geometry question where we basically will use properties of incircles and circumcircles and so on. The question is stated as follows. Let ABC be 3 points on a circle and PQR are the midpoints of the arcs BC, CA and AB respectively. So you can see that I have marked A, B and C on the circle and PQR are the midpoints of the arcs. So arc BC's midpoint is P, arc AC's midpoint is Q, and similarly arc AB's midpoint is R, right? When I join the lines AP, BQ, and CR, these lines intersect the lines BC, CA, AB at L, M, and N. So these are the points L, M, and N, right? The center of the circle is at O. O is this point, which is the circumcenter. Also, the point of intersection of the three lines AP, BQ, and CR is the in-center of the triangle. This is the I, this is the in-center. Why have I been able to say that this is the in-center? Because if you think about it, the arc BC was being bisected by P point, right? So this length of arc is equal to this length of arc. So the angle subtended by arc BP at A, which is this angle, will be equal to the angle subtended by arc PC at A, which is this angle. This is a standard property of circles that if there is an equal arc, it will subtend equal angle at a point on the circumference of the circle, right? So this angle is equal to this angle. That means the line AP is an internal angle bisector of angle BAC. Therefore, similarly, BQ is also an internal angle bisector and so is CR. Therefore, the point of intersection becomes the in-center, right? Now, in this question, what we have to show is that AL by PL plus BM by QM plus CN by RN is greater than equal to 9, right? This is an actual Olympiad question from the late 90s. And let's discuss this question. This could be a question which could appear even in JEE Advanced because similar types of concepts have been utilized in the past. So let's see how we approach this problem. First of all, what is AL? AL is the length of this internal angle bisector, right? Till here, this is AL, right? And PL is this length. Similarly, BM is this length and QM is this length, right? And so on for CN by RN, right? So in some sense, we have to find out the length of the internal angle bisector of the triangle, right? Now, for people who are familiar with properties of triangle, this is a standard result. We can directly write AL, but I will not assume that and I will show you how you can get it, right? So what we will do here, we realize that AL bisects the angle A. So therefore, we have a simple geometry property that the internal angle bisector cuts the opposite sides in the ratio of the sides containing that angle. So what that means is L point divides BC segment in the ratio BL by LC should be equal to the ratio of the sides containing the angle. AL was the angle bisector of angle A. And what were the sides containing that angle? That was AB by AC, right? AB by AC. So AB by AC, we'll use typical triangles notation. So AB side will be called small c and AC side will be called small b. So BL by LC is C by B. And obviously the BC length is A. So therefore we can find ratio BL plus LC is equal to BC. Therefore we can say CK plus BK is equal to A. So K comes as A by B plus C. Therefore, BL, which was CK, can be written as BL is B times CK. So C times A by B plus C. And similarly, CL is BK. So this is B times A by B plus C. How did I get this? I know the ratio that L divides BC, and I know the total length of BC is A. So I just have to split A into ratio of C is to B, right? So obviously it will be C by B plus C into A and B by B plus C into A, right? So that is my BL and CL, right? Now that we have BL and CL, what we'll try to do is find AL, right? But to do that, I will take advantage of area of the triangle. So what I will say is triangle ABL plus triangle ACL will add up to the area of the overall triangle ABC, right? I'll just write that here. Triangle ABL plus triangle ACL area should add up to area of triangle ABC, right? And ABL area can be written as half into AB into AL into sine A by 2. So that becomes C into AL into sine A by 2 plus half into ACL area will be half into B into AL into sine A by 2. And that should be equal to half into B into C into sine A. This is using the half BC sine A formula for area of a triangle. And if you solve this, AL can be simplified and you'll cancel the half first of all, half from everywhere. And then you will say it is BC sine A divided by B plus C sine A by 2, which can simplify as 2BC by B plus C cos A by 2, right? So this is the standard result I was talking about. This is the length of an internal angle bisector, right? This is a result that is very frequently used in JEE preparation, and you can find it in SL Loney. And this is a good way to derive it, right? So we have AL length, right? We also have BL length, we have CL length, right? However, we don't have an understanding of PL length yet, right? So what I will do is I'll try to figure out what PL length should be, correct? So let me just rub off the statement of the problem for now, and we will get some space to work with here. We want to preserve the diagram here. So I will just write and try to find out PL here. So to find PL, notice one thing. Notice the L point. L point. What is the power of L with respect to power of point L with respect to circumcircle, right? Power of point L can be written as PL into AL, right? Because PL into AL, because this is an internal point, so distances of the point from the two ends of a secant, right? That is your power of a point. Also, it can also be written as LB into LC, right? Or BL into CL. This is BL into CL. And we already know BL into CL. We have BL here, we have CL here. So what we get from here is this relation AL into PL is equal to BL into CL is BC A square by B plus C whole square, right? Let's keep this relation. This is the first relation. We also have this relation here, right? And what I will do now is try to simplify this by using cos A by 2 here. Cos A by 2 in which triangle? I can take any triangle. A by 2 is an angle here, A by 2. So I know that cos A by 2 by applying cosine rule in triangle ABL will be AB square, which is C square, plus AL square minus 2 minus BL square minus BL square by 2CAL, right? This is my cos A by 2, right? Great. So can I use this cos A by 2 formula here and get a different relation? Yes, we can. So what we will do here is we'll work in the next screen now, and we'll say AL is equal to 2BC by B plus C into cos A by 2, and cos A by 2 is coming out to be C square plus AL square minus BL square by 2C into AL, right? From here, I want to solve for AL square, right? So I will just write 2C gets cancelled here, and this becomes B. And B plus C and AL goes on the other side. So that becomes B plus C into AL square is equal to B times this top part here, right? That is BC square plus BAL square minus BBL square. Correct? Great. So now, if you can notice here, there is B times AL square on both sides of this equation, right? So B times AL square will get cancelled. B times AL square gets cancelled and B gets cancelled here. So you are left with CAL square is equal to BC square minus BBL square. B times and BL square was what? BL was CA by B plus C. This is B square, C square, A square by B plus C whole square, right? Great. So AL square I am able to solve for, and I can say that AL square will be equal to BC minus BC A square by B plus C whole square, right? Great. So this is my expression here. I can take BC common here and I get B plus C whole square minus A square by B plus C whole square, right? This is my AL square, right? Great. Now, earlier we had done power of a point and we had gotten the expression AL into PL was equal to A square BC by B plus C whole square, right? So if you think back to the problem, in the problem we had to prove that AL by PL plus BM by QM plus CN by RN was greater than equal to 9, right? That was the objective of the problem. Now we have one relation here, AL square, in terms of the sides of the triangle. We have another relation from power of a point, which is AL into PL is this. So now we can easily construct this ratio now, right? We can divide this by this. We'll get AL by PL, right? AL square by AL into PL will give you AL by PL. And what is that? That is the division of this by this. So notice that B plus C whole square will get cancelled. And what I'll have here is BC, B plus C whole square minus A square divided by A square BC. Now BC gets cancelled here and you get basically B plus C by A whole square minus 1. That is my AL by PL, right? Great. So by symmetry, if AL by PL was coming like this, similarly BM by QM should come out as C plus A whole square by B minus 1. And similarly CN by RN should come out to be A plus B whole square by C minus 1, right? So that is obvious because we follow the same steps. Once we have gotten one symmetric quantity in a triangle, we can extrapolate and get the others. Now let's evaluate the left-hand side here. So what we get is AL by PL plus BM by CM, BM by QM plus CN by RN is equal to, you get B plus C by A whole square plus C plus A by B whole square plus A plus B by C whole square minus 3, right? Minus 1, minus 1, minus 1. Great. Now let's analyze this. B plus C whole square by A square. That is actually equal to B square plus C square plus 2BC by A square. And that will be greater than equal to 2BC plus 2BC by A square, right? Because we know that B square plus C square is greater than equal to 2BC by ANGN. ANGM inequality, right? So we can say that this is greater than 4BC by A square, which is equal to 4ABC by A cube, right? So we can say that B plus C by whole square by A square is greater than equal to 4ABC by A cube. So we write that expression everywhere here. We can say that this whole thing is greater than equal to B plus C by A whole square, C plus A by B whole square, plus A plus B by C whole square is greater than equal to 4ABC by A cube plus 4ABC by B cube plus 4ABC by C cube. And we can apply ANGM on this also. That will be greater than equal to 3 times cube root of 3, 4ABC by A cube, the product, with 4ABC by B cube and with 4ABC by C cube, right? So if you see here, ABC is coming 3 times on top. So A cube, B cube, C cube will cancel with the denominator and you get 4 cube here. This is 3 times 4. So this is greater than 12, right? So if this expression is greater than equal to 12, obviously this expression will be greater than equal to 9, right? So we have shown that AL by PL plus BM by QM plus CN by RN is greater than equal to 9. What were the concepts that we used in this question? The first thing to realize is that it is an internal bisector situation. Once it is an internal bisector situation, we can basically figure out if there is any triangle and this is an internal bisector. I know how this part and this part will be, right? Because the ratio of that will be C is to B, right? So this part became C by B plus C into A, and this part becomes BA by B plus C. So we knew BL, we knew CL, and now we knew AL also by using area of this triangle plus this triangle is equal to the whole triangle. So we found AL was 2BC by B plus C cos A by 2. Then what we did was applied cosine rule in this cos A by 2. Cos A by 2 we wrote as cosine rule in this triangle. Once we wrote that, we were able to get AL, just AL square technically, just in terms of A, B, and C. And by power of a point, we already had AL into PL was equal to BL into CL. And BL into CL distances were known. So AL into PL was also known in terms of A, B, and C. Using this and using this, we divided to get AL by PL, right? And after that, the problem was a simple application of AMGM twice. We applied AMGM once to say that B square plus C square is greater than or equal to 2BC. And at the end, we applied it on 4ABC by A cube, 4ABC by B cube, and 4ABC by C cube, right? So this is a nice question which combines your knowledge of geometry as well as a little bit of algebra, and being very focused on what is our target and not getting distracted while solving a problem, not finding other things that are unnecessary, right? So hopefully you learned something from this video, and we can discuss in the next videos new problems with more concepts which are similarly enlightening, right? If you like the channel, please subscribe to the channel, and I'll provide more content for JEE Advanced and Olympiads. See you in the next video.